In this video, we're going to talk about nominal interest rates and nominal discount rates. So Jeff has a little bit of money. He's got $10 that he's going to deposit into a fund today, and then another $20 that he's going to deposit 15 years from now. For the first 10 years, interest is credited at a nominal discount rate that's been compounded quarterly. And then after that time, for the next 20 years in essence, because we're looking at the balance after 30 years, for the next 20 years, the interest will be credited at a nominal interest rate of 6% compounded semi-annually. We're told that after that 30-year period, the balance is 100, and they ask us to calculate the discount rate, the nominal discount rate. Okay, so looking at our accumulated value accumulation factors, I should say. Okay, the $10 sits in there for the whole 30 years. Well, that means that it sits in there getting a compound discount rate for the first 10 years and then the compound interest rate for the next 20 years. Since the discount rate is being compounded quarterly for the first 10 years, there are 40 compounding periods. Since we're told that D is a nominal interest rate, because it says D compounded quarterly, we'll have D over 4 on the inside. So the accumulation factor for the first 10 years is 1 minus D over 4, and we'll raise that to the negative 40th. So remember, nominal interest and nominal discount rates, you're told that for, basically it's quoted as a yearly rate, but it's divided into pieces depending on how many times per year it's being compounded. So the D over 4 is that interest rate per period. Likewise, then after that first 10 years, it sits in the account for another 20. For that 20 years, we're getting the interest rate compounded semi-annually. We're quoted a nominal interest rate of 6%. We divide it by 2 because that's semi-annual periods. And there are 40 semi-annual periods, so our accumulation factor for that last 20 years is 1 plus 0.06 over 2 raised to the 40th power. For the $20 deposit, it's only subject to the compound interest, not the compound discount. So it sits in there for 30 compounding periods because it's compounded semi-annually for 15 years. So that accumulated value will be 20 times 1 plus 0.06 over 2 raised to the 30th. When we take the total of those two accumulated values, we have to get 100. So we get this equation of value here. If we solve for 1 minus D over 4 to the negative 40th, after you do all your computations, you'll get 1 minus D over 4 to the negative 40th is about 1.58. So now, solving for D by doing the 40th root and reciprocating, switching sides around and multiplying by 4, that's what all the algebra would be to get to this point, you see that you get D is about 4.532%.